Hello. So in physics, power refers to the rate of work done. So if the work goes into changing a certain form of energy, power can also refer to the rate of increase or decrease of that form of energy. Take for example a mass being pushed by a constant force F. What is the rate of increase of its Ke? So we'll need some math here. So K is half mv squared, and we can write V as At. How come? Because constant force, constant acceleration. So V is equals to U plus At, right? So I'm assuming that the mass starts from rest, yeah? So V is equals to At. Open up the bracket. So if we plot K against time, what kind of graph do we get? Half ma squared are constants, right? So it's just a t squared there. So it's a quadratic graph. The gradient of this graph is of course the rate of increase of Ke. So to obtain the power, let's differentiate the Ke with respect to time. Do the math, you get ma squared t. Recognize that ma is actually that constant force F, and At is actually V. So power is F times V here. I find it quite interesting because even though the force is constant, the power is not constant. The rate of increase of Ke actually increases with time as you go faster and faster. Let's try another example. This is a vertical drop. We let a mass m free fall. Yeah. So what's the rate of decrease of its GPE? GP is of course mgh. Mg is constants, which means if I know how h varies with time, I know how GPE varies with time, right? So the ht graph, do you agree, is this? It's just a quadratic graph. It's a vertical fall, yeah? So the ht graph has this shape, and therefore the GPE graph will also have this shape. Again, the gradient of this graph is the rate of decrease of GPE. So the power we can obtain by differentiating the GPE with respect to time. Do the math, we end up with mg dh dt. What is dh dt? It's the rate at which your height is falling, which is basically the vertical velocity. So again, even though the force is constant, the acceleration is constant, it turns out the power is not. The mass is losing GP at faster and faster rate as it falls faster and faster. Alright, that's all. Ta-ta!